Now let's draw this as an electric circuit diagram. So let me start off with this. That can be one end of the circuit on the Arduino board, and we'll draw the other end over here on the Arduino board here. So this will be a 5-volt potential difference from there to there. 5 volts. This will be the 5-volt port on the Arduino board. This over here will be the ground on the Arduino board. Okay, and using the correct symbols this time. That's positive 2 and that's negative down here as well. Right. I'm going to draw the components, and as I said before, it doesn't matter if I put the resistor in front or behind the LED, because once I insert the resistor, it will control the current in every part of the circuit. In a series circuit, everywhere around the circuit, the current is the same. Alright, so now I draw my light emitting diode or LED, and it's drawn as a triangle symbol with a flat thing like that, and because it's a light emitting diode, I also draw these little arrows, which means light's coming out. So that's an LED there. And now the other end here, I'll draw one of the symbols for the resistor is a zigzag. Some people draw a rectangle, but I draw a zigzag. So I do it like this, and that's enough zigzagging. And down here. So now keep in mind that when we draw the light emitting diode, that the positive end is this side here where the triangle is, and the negative end is this side here where the line is. Okay, negative, positive. So what we need to do now is I've chosen my LED, which is a blue one. Okay, and I need to work out to control the amount of current going to my LED so we don't burn it out, or we don't give it enough current. We need to make sure that this thing here is the right resistance in ohms. So let's do some calculations. Very simple. So we already have decided that we must have a current under 20 milliamps and ideally over 10 milliamps. If it's too low, it'll be too dim. So everywhere on a series circuit, the current is 20 milliamps, shown as 20 and little m for milli and big A for amps. So here too is 20 milliamps, and here too is 20 milliamps. Okay. Now what exactly is 20 milliamps? Now when you do your calculations, you must convert everything into amps, not milliamps, volts, not kilovolts, not microvolts, not millivolts, volts. And ohms are going to be in normal ohms, not mega ohms or milliohms or whatever ohms, just ohms. So everything has to be in standard units. So 20 milliamps, that's our current. So in the formula of Ohm's law, we use the symbol I for current, not C. Alright, so we have 20 milliamps. But in terms of amps, what is it? So let's do a calculation. So 20 milliamps is 20 over 1,000 amps. Right, which equals 0.02 on a calculator. Let's do that to be sure. 20 divided by 1,000 equals 0.02. Great. So now we're going to use Ohm's law to work out the required resistance of this guy here, the resistor. So let's draw the Ohm's law diagram again, and here it is. The easy way to remember things. I draw my horizontal line there, my vertical line there. We'll put V for voltage here, I for current here, R for resistance here. Okay. And just keep in mind that this horizontal line means divide, and this vertical line means multiply. So I want to find out the unknown is resistance, because I know I can work out the voltage, I know the current, which is no more than 20 milliamps. Therefore, what is the resistance? Okay, so if I've chosen a blue LED, okay, A blue LED, this guy here, according to this, it's going to be about 3 volts. Alright, so let's draw this on here. So down from there to there, the potential difference is 3 volts. Okay, now remember my input supply is 5 volts. Therefore, virtually the rest of the voltage in the circuit is used up by my resistor, which is going to be 5 minus 3 equals 2 volts. So therefore, this resistor is going to use up 2 volts of energy, or electromotive force. Now I can use that for that 2 volts go into here, that current goes into here to work out that. So let's work out the formula for resistance. So I put my finger over the R for resistance. Therefore, resistance equals voltage over current, or voltage divided by current. Okay, so here's the formula. R equals V over I. V over I. Put the values now into the equation. So we know V is here, it's 2 volts in the resistor, divided by the current, which worked out. And remember, all the units had to be in standard units, not milliamps. It has to be in amps and volts and so on. So we've got our values in the equation, and let's work it out. As you can see, without even using calculator, we know that this is 100th of that, but let's just do it anyway on the calculator. So clear, 2 divided by 0.02 equals 100. So 100 ohms is the result. We need a resistor of 100 ohms, and please don't do any less than that, because you reduce the life of your LED, and not too high either. So if you don't have quite the right resistance with your resistors, then just try and get it approximately to that number. So try and get it to about 100 ohms, and ideally more than 100 ohms, not less. Now for this exercise, we're going to use, with this LED and the blue one, a 100 ohm resistor. Now if you don't quite have a 100 ohm resistor, don't despair. If you have a more powerful resistor with a higher resistance, like 200 ohms or whatever, it means that you're reducing the current to the light, which means it's going to be dimmer. Not a big deal. Now if you have a resistance which is less than 100 ohms, it means you can have more current flowing to your LED light, which means it's going to be brighter, which may seem like a good idea, but you also are reducing the life of the LED lamp. Okay, so if it's too much current going through here, you'll burn it out in no time, even within a few seconds. It may actually flash, and then they'll be dead. Dead LED is useless, so you have to chuck it away. So if it's about 70 ohms or 80 ohms, 90 ohms, it's no big deal. But if you're building a permanent project, not just prototyping, you want to get the right resistance. If you're just testing 70, 80, 90, no big deal, don't worry about it. But for long-term installations, get the right resistance. And if it happens to be more than 100, maybe 120, 130, 140, it just means you can have a dimmer light, but your LED will last longer. But just keep in mind, the ideal current for these typical LEDs is 20 milliamps. So, and it should never be more than that.